All right, geniuses. Today we're going to be talking about double angle identities. So you'll have a grand whopping total of 3 identities on this test. You'll have sum, difference, and double angle identities. If you want to check your homework from last night, here are the answers there. I'll zoom in so you can see these better. Number 1, you of course would need to show more work, but those are the answers that you should have come up with. And number 2. You did not have to do the back. So, double angle identities are given to you at the top of your notes. You'll check those out. There's 2 of them, and you might want to make a note here that you do not have to memorize. So when you're asked to find the sine of 2 theta, you can't just find the sine of theta and multiply it by 2. You'll use this lovely formula here. You'll take 2 and multiply it by the sine of theta, and then by the cosine of theta. And then if you want to find the cosine of 2 theta, you cannot just take the cosine of theta and multiply it by 2. You have to do cosine squared minus sine squared. So those are the 2 formulas we're going to practice using today. Just like yesterday, your problem is going to start off by giving you some information about our triangles. So on number 1, we're given that the sine of theta is negative 4 over 5. So we know the opposite is negative 4, the hypotenuse is 5. We're also given that the angle theta is in between 3 pi over 2 and 2 pi. So that puts us in quadrant 4. So just like yesterday, we draw our triangle. We form our right triangle with the x-axis. We know the opposite is negative 4. We know the hypotenuse is 5. And the other leg, of course, would be 3. It would be positive 3 because it's moving right on the x-axis. We're going to label our O, A, and H because that'll come in handy again today. If we want to find the sine of 2 theta, we cannot just take the sine of theta and multiply it by 2, like I was saying up above. We have to use our double angle identity, which says that we're going to take 2, multiply it with the sine of theta, multiply it with the cosine of theta. And then you just plug in piece by piece, just like yesterday. So we would have 2 times the sine of theta would be the opposite over the hypotenuse, so negative 4 over 5. Times the cosine of theta, which would be the adjacent over the hypotenuse, so 3 over 5. If you want, you can multiply straight across and do it by hand, or you can plug that into your calculator. If you multiplied straight across, we'd have 2 times negative 4 times 3, so negative 8 times 3, which would be negative 24 over 1 times 5, which would give us 25. So that's how you use double angles with sine. Let's try it with cosine. If we want to find the cosine of 2 theta, we're going to use the formula cosine squared minus sine squared. So we go back up to our triangle. We find the cosine of theta, which is 3 over 5, and we're going to square it. Minus the sine, which is negative 4 over 5, and we're going to square it. Just make sure if you are going to use a calculator that you wrap your fractions in parentheses or your negatives in parentheses when you square them, because a squared negative turns positive. If we squared 3/5, we would get 9 over 25 minus negative 4 squared would be 16, 5 squared would be 25, and then simplify from there. 9 minus 16 will give us negative 7 over 25. It's nice when it's a Pythagorean triple because you don't have any radicals or anything, and you could plug a lot of that in your calculator. Let's try out number 2. Number 2, we're given that the cosecant of theta is root 5. we're going to take a moment and we're going to put that over 1 and remind ourselves that cosecant is related to sine. It's the reciprocal of sine. So we should have the hypotenuse over the opposite. We're also given that theta is in between pi over 2 and pi. So we are now in the second quadrant. When we draw our triangle in the second quadrant, remember that you have to be careful about the legs because they could be negative. So we have the cosecant is the hypotenuse over the opposite. We'll go to the side and do our Pythagorean theorem. So we have x squared plus leg squared equals hypotenuse squared. You end up getting x squared equals 4, so x should equal 2. When you put that 2 on the triangle, though, make sure that you're being careful to make this negative. Pythagorean theorem is always going to give you a positive answer. When you put your leg on the triangle, you need to check to see if it should be a positive or negative leg. Otherwise, your whole answer will mess up. So now we got a different triangle. If we want to find the sine of 2 theta, we use the same formula. 2 times the sine of theta times the cosine of theta. And we plug in what we've got. So we have 2 times sine would be the opposite over the hypotenuse. So 1 over root 5. Don't worry about rationalizing. It'll all come out in the wash. And then the cosine, make sure it's negative 2 over the square root of 5. Stick that initial 2 over 1, and we can multiply straight across. 2 times 1 times negative 2 will give us negative 4 over root 5 times root 5 gives us 5. If we want to do the cosine of 2 theta, we'll do cosine squared minus sine squared, using our double angle formula from up above. So we'll take our cosine, negative 2, over the square root of 5. We're going to square it. Minus the sine of theta, the opposite, over the hypotenuse, squared. You can plug this in your calculator, but you can also just do it by hand. If we just square each individual piece, it's going to be just fine. If we take negative 2 and square it, you get 4. If you take root 5 and you square it, you get 5. Minus 1 squared gives us 1 over square root of 5 squared gives us 5. They have a common denominator. We bring them together to get 3/5. Zoom out if you need to get anything on that page that we might have missed. Go ahead and snag it now. We'll do a couple more on the back. Cosecant. Yeah. All right. This one looks a slight bit different. We're given the cotangent just like before, so we stick it over 1. I guess we weren't given the cotangent, sorry. We were given the cotangent. So now this is the one that's related to tangent. So if tangent is opposite over adjacent, this one's going to be the adjacent over the opposite. Notice how it's negative. So we're given a negative cotangent. And we're also given this piece of information, that our secant is less than 0. If our secant is less than 0, that means cosine is also less than 0. So that means we have a negative cosine. So we're going to go back to what we reminded ourselves of yesterday. All students take calculus. And we're going to use the fact that cosine is negative to eliminate some quadrants. So if cosine is negative, we know it's not in quadrant 1, and we know it's not in quadrant 4. We're also given that our cotangent is negative. If cotangent's negative, then tangent is also going to be negative. So we can also eliminate quadrant 3, putting our final triangle in quadrant 2. So we're going to draw a triangle in quadrant 2. And we're given that the adjacent leg is -3, opposite leg is 1. If we want to find the hypotenuse, we're going to do the Pythagorean theorem. So we'll have leg squared plus leg squared equals our hypotenuse squared. When you square -3, you should get 9 plus 1 equals x squared. X squared equals 10. So we get that the hypotenuse is square root of 10. The hypotenuse is the one side of the triangle that you don't have to worry about. It's always going to be positive. If it helps you to label your O, your A, and your H, might be a helpful time to do that now. All right, now that we've built our triangle, we can find the sine of 2 theta by using that same formula as the page before. 2 times the cosine of theta times the sine of theta. So we'll have 2 times the sine would be the opposite over the hypotenuse. So 1 over the square root of 10 times the cosine would be the adjacent over the hypotenuse. So we get -3 over the square root of 10. Stick that initial 2 over 1 and multiply straight across. 2 times 1 times -3 gives us -6 over root 10 times root 10 gives us 10. And we can simplify that to -3/5. Finally, if we want to do cosine of 2 theta on this guy, we're going to do cosine squared minus sine squared. The order matters when you subtract, so make sure you're copying that down right. So we would have the cosine adjacent over hypotenuse squared minus the sine, which is 1 over the square root of 10 squared. If you wanted to do it in your calculator, you can. Square each individual piece. So if we have -3 squared, it should come out +9 over root 10, the denominator squared, we would get 10 minus 1 over 10. 9/10 minus 1/10 gives us 8/10, which simplifies to 4/5. All right, in our final one, we're given that the cotangent is 24 over 7. So remember, cotangent is the reciprocal of tangent. If tangent's O over A, cotangent is A over O. Then we're just told which quadrant it's in between pi and 3 pi over 2. That gives us quadrant 3. Take a moment, build your triangle. Now, when you put this on the triangle, initially it looks, the cotangent is positive. But when you put this on the triangle, make sure that you're making both of these legs negative because we're going left and down. This is a Pythagorean triple. If you don't know that Pythagorean triple, you can do the Pythagorean theorem over to the side. We fortunately used this triangle yesterday. 7, 24, 25 is a Pythagorean triple. Label your O, your A, and your H. And we can finish up once we've built our triangle. If we want to find the sine of 2 theta, we'll do 2 times the sine of theta times the cosine of theta. So we'll have 2 times the opposite over the hypotenuse. So -7 over 25 times the cosine, the A over the H, -24 over 25. You can plug that into your calculator, or you can multiply straight across. We get 336 over 25 times 25 gives us 625. I'm not sure if that simplifies down. It doesn't. So that is our happy answer. And our last one, we'll do cosine squared minus sine squared. So we would have the adjacent over the hypotenuse squared minus the opposite over the hypotenuse squared. And we're just going to take that one and we're going to plug it into the old calc. Doesn't give us a very satisfying answer, but you should get 527 over 625. Got a couple to try out on your homework. Hopefully that is not too bad for you. You can always email me if you have specific questions. I also have enrichment tomorrow on Thursday if you want to come ask any questions then. Have a good day.